Hello everyone, I welcome you to my YouTube channel. How are you guys doing? I hope everything is okay. Okay, today is part 2 of this video. We did part 1 of this video, so if you haven't watched it out, just go and watch part 1 so that you'll be able to understand this part 2. I would like you to go back and watch part 1, please, so that you'll be able to understand, because in part 1 I used block diagram and hardware solution to explain how backlight circuit works. So in this part 2, it's going to be brief, very brief. So I'm going to use schematic diagram to show you how to trace this backlight circuit. So make sure that you go back to our channel, our page, and then watch part 1 so that you'll be able to understand. All right, I want you guys to fasten your seatbelt. Okay, so let's dive in. Okay, here I have backlight driver, this backlight circuit in schematics, and this is my sys model. So we know that the input line, the line that supplies voltage to our backlight IC is VBAT, or you can call it VPH or V6, depends on the model. So in this model they use VBAT. It's 3.7 to 4.2. So we have capacitors here, we have 0 ohm resistor, we have capacitor here, like filtration caps. So in this one, this other caps is not connected, it's NF, not fixed, it's not connected. You see only one cap in this line. So you test it to see if you get your 30.7 to 4.2. So after that line this line goes to this coil. It also comes out and connect to pin number 6, that is V voltage input pin. So the same line connect to this coil. I showed you how to test and troubleshoot these lines. So I'm just tracing, using this schematic to trace to show you. So the same line also comes back and enters your switching pin. This is the pin that acts as a switch, pin number 4. So it acts as a switch. So this line is also connected to one side of this diode, and this is the positive side. This diode, this number 2 is a positive side. So the line connect to this positive side and then comes out from the negative side. You know, diode allowed current to pass. It has one direction. It allows voltage to pass without reversing back. So that is the main function of diode, but we have other functions. So you have to test to see if the voltage gets here. We have a capacitor here and one big coil here. It's a coil here. In some models you will not see the coil. So this line, all this cap, you can test and see if it's receiving voltage. So this line, this LCMB, goes to another page, which is your connector, your screen connector. So this is how you trace it using schematics. I explained vividly to you in my part 1 how to troubleshoot this backlight. So I'm just showing you how to trace using schematics. The testing, the troubleshooting is my part 1, so go and watch out. So we have a capacitor here. It's NF, it's not fixed. This capacitor is not here. Anywhere you see NC or NF, know that that component is not there. So this line comes straight and enters pin number 50, which is our connector. So you test this line to see your 3.7 to 4.2 volts when you have not clipped your screen. But when you clip your screen, the voltage will change. So now we have pin number 1 here still on our backlight. I see feedback. This pin acts as our cathode, our lead cathode. So in this line we have 2 resistors here that are connected to ground. This is a pull down resistor. This resistor has its own work. This is what we call pull up resistor and pull down resistor. So we also have a capacitor here, and so this line is LCM lead cathode. This is our negative side of our anode. So this line connects to this is a divided circuit, but this circuit is not functioning because it is NF. The R2, our R2 here is 0 ohm, but it's NF, it's not fixed, so there is no divided circuit here. So we move this line, connect to pin number 13. Okay, it's pin number 13 on our LCM connector. So this is how you measure. You must ensure that this line is being fixed. If this line is not connected, that means our backlight is not gonna work. So let's go back. Let's go. This is LCM LED cathode. We are done with that one. Okay, so we have two pins here, pin number 3 and pin number 7. They are all grounded, they are connected to ground. You must also make sure that these lines are connected. Okay, so we have pin number 2 here, comp. This other pin, it has a pull down resistor here. Okay, it's not the one. It has the capacitor here, and this capacitor is not there, it's not mounted. And we also have a resistor in series, and this resistor is not mounted. So this line also connected with our own flash. It's connected to GPIO. So this line goes straight to our CPU. This is our CPU section. This section carries 1.8 volts. So this line goes straight to our CPU. This line enables our CPU to also communicate with our backlight IC. So we have another line here, pin number 5, controlling line. And this line has 2 lines, and it has a pull down resistor of 100k. So this line has to generate 2 lines. This other line, the resistor is not mounted, but in this other line we have 1 resistor here. It should be 0 ohm resistor. So this line goes to our CABC, that is our content adaptive backlight control. So this content adaptive backlight control goes back to our connector. I explained to you the function of this line. This line is very important. You must ensure that this line is working. Okay, so this line also connects to another line. This is a line that supplies voltage to this line. It's a line. Let's check out this line. It's a line that supplies voltage to this line. Most time the voltage is always 1.8 volts, but in this model we have 2.8 volts. This line connects to this pin number 39. So this line also connects to some resistor here. This is 0 ohms resistor. It's not fixed. There's no resistor there. So this line we have VDD 2.8 volts. This VDD is our voltage line that comes from our power IC section. So it supplies 2.8 volts. 2.8 volt to this CABC. If this voltage is not there, this phone is not gonna have light. So you must ensure that this line is connected, and that 2.8 volt is supplying. So this is our power section. As we check this line, this is our power section. This is from our LDO section. So you must ensure that you get this volt. If you haven't seen this volt, you tap from this capacitor. And these are the other side that this voltage is connected to. You also have other section that the same 2.8 volt is connected to. So these are our fingerprints IC. So you can tap that 2.8 from any of these sections. This is our battery temperature monitor. This is our temp for sensing temperature now. Circuit, this is it. So you must ensure that this 2.8 volt gets there. So now let's go back. So you copy this line and let's next it. Okay, so we have finally come back to our backlight circuit. It's very easy to troubleshoot. If you watch it by one very well and understand, you will know how to trace these lines very well. And I told you the function of this line. It helps control the brightness of our screen, and also helps to signal our backlight circuit that the screen is connected, that they should start processing. So this other line, PWM, comes to this is our power IC section. It is connected with this keypad button. This is 1.8 volt. It's keypad. Now the function of this line is that if you put your phone to sleep using your power button, you sleep your phone, you put your phone to sleep mode, it is this line. This line helps to signal that power button. The power button line helps to signal this backlight IC that the light should goes off, because you have switched it off. You've put it in sleep mode. So as you press your power button, this line signal the backlight IC that the light should not come on. It should go to sleep. It's time to sleep. So your phone backlight will sleep. So this is the function of this line also. two line comes out. One is connected to our connector, the other line goes to our power IC key part section. So this is how your backlight circuit works. If you have questions, if there's anything I explained that you don't understand, feel free to ask. Just drop it on the comment section, then I will attend to your question. Okay, thank you. See you again in my next video.